Greetings, TMES Academy of Science and Commerce, Department of Physics. Okay, basically these videos are made for the quick revision of the practicals for the upcoming 2024 practical examination. So in this video, we are going to do a quick revision of refractive index of a glass slab. Refractive index of a glass slab is basically a fixed one with respect to air. The value of refractive index of the glass slab is 1.5. 1.5 with respect to air. So the aim of the experiment is to determine the refractive index of a glass slab using glass slab and a traveling microscope. These are the two apparatus we are going to use. The refractive index of a glass slab with respect to air is the ratio of real thickness of the glass slab to its apparent thickness. This is nothing but a phenomenon of normal shift. When an object in a denser medium is seen through a rarer medium, the object at the bottom appears to be raised in a denser medium. Therefore, the refractive index of the medium, denser medium where the object is placed, can be defined as real depth divided by apparent depth. So same formula we use here. The formula of the refractive index with respect to air is given by R3 minus R1 divided by R3 minus R2, where R1 is the reading of the microscope when we focus on the ink mark through air, means when we have seen an object through air, okay, and R2 is of the microscope when focused on the ink mark through the glass slab, that is through the denser medium, and R3 is the reading of the microscope when focused on the powder. This powder can be utilized or used as a reference axis from where we are actually measuring the distance of the object through air and through the medium. Therefore, that is the reason to measure the distance, we use it as R3 minus R1, which gives the real depth, R3 minus R2, which gives the apparent depth. And since a vernier calipers is mounted for an telescope, this traveling microscope, so it should be calculated. The distances R1, R2 and R3 is calculated using the formula TR is equal to MSR plus CVD into LC. So this is the traveling microscope. This traveling microscope from 2 to 3 means between two numbers there are 20 divisions. Therefore, value of each division is 0.5, 0.05, pardon. And the total number of small scale, that is 0 to 0.5, it is called a small scale or vernier scale. The total number of vernier divisions are 50. Therefore, the least count of the microscope is 0.001 centimeter. Least count means it is the least that we can measure from this microscope. And it has a 3 stages. First stage is just R1, calculating R1 means focusing on the object or an ink mark through air, and R2 focusing on the ink mark through the glass slab, and R3 focusing on the powder, which we will understand in an upcoming simulation. It is very much similar to what we do. This telescope is mounted with a vernier calipers. This scale, okay, what we call it as small scale. Okay, this scale, what we call it as small scale, or it is also called as vernier scale. Okay, vernier scale. Here we have 0 to 0.5, we have 50 divisions. Therefore, the total number of divisions in a vernier scale is 50. And if you see here from 2 and 3, there are almost all 20 divisions. Therefore, the value of each division, one division is 0.05. If this is 2, this will be 2.05, and this will be 2.1, 2.15, 2.2, 2.35, 2.3, 2.35, 2.4, 2.45, 2.5, like this it keeps on going till here. Each value of each line is 0.5. So This is a telescope and the scale is mounted on the other side. This is a fine adjuster which can be used to move up and down of the telescope. And this is the screw. If you want to move little larger distance, you can loosen the screw and you can adjust this and you can tighten the screw. This is the focus. So no need to adjust the focus in the beginning. Only in the beginning you can adjust, and better thing is use this and this. So here first what we do, we place a paper and we'll rotate the screw fine adjuster. When we rotate the fine adjuster, we should adjust such a way that it should have a clean and clear image of the ink mark what we placed exactly below the telescope lens. So the first and foremost thing we have to do here is we have to note down the reading of MSR and CVD. This trial is noted as R1. This trial is taken as R1. So now if you see the MSR, this is the zero of the vernier. It is approximately very close to some value in the main scale. That value is approximately 2.65. If you observe here, it is 2.565. Why means this is 2 means this is 1.9, this will be 1.8, and this will be 1.7, and this will be 1.6. The value between 1.7 and 1.6 is 1.65. Okay, the value between 1.7 and 1.6 is 1.65. Pardon, 1.65. So now my MSR in this case is 1.65. And CVD. CVD, see here, this 0 is not actually perfectly coinciding with the 1.65, but here this is perfectly coinciding with this value. In MSR, you should take the reading of the main scale, and in CVD, you should consider the value which is perfectly coinciding with any of the graduation. That too, we have to consider this value, that is the value on the vernier. This is from 0 to 1, it means in general it is 10 divisions. So now my CVD is 10 divisions. I repeat, my MSR is 1.65 and my CVD is 10. So we use it in a formula. Total reading is equal to MSR plus CVD into LC. And you should not by heart these readings. You should check with whatever the readings you are getting in your experiment. Now, after doing this, what we should do means we will place a glass slab. And when we place a glass slab on it, again we'll see a blur image. Again, we should raise this telescope using either this or this. So I'm using it. So I got a clear image, very clean image. Now I will stop raising the telescope. Again, I will check with my MSR and I will check with my CVD. If you see here, my MSR is very close to 1.95. Therefore, my MSR will be 1.95. And my CVD, if you check here, this line is perfectly coinciding with this. Therefore, my CVD will be 11. And this reading gives me R2. Okay, this reading, placing a glass slab will give me R2. Now I put a powder, any talcum powder or chalk powder. Now again we'll adjust it. Again so that we'll get a clean image. Again same process. We'll check for MSR. Here the MSR is 2.65. Okay, 2.65. And since you can observe it here, this is 3, 2.9, 2.8, 2.7, 2.6. Therefore, it will be 2.65. My MSR is 2.65 and my CVD, if you observe here, the fifth division from the 0 is coinciding perfectly. Therefore, my CVD is 5. And this reading constitutes me R2. After getting R1, R2 and R3, I'll put it in a formula R3 minus R1 divided by R3 minus R2. So the whatever things we'll get, we'll tabulate it here and we'll do the calculations and we'll find out the refractive index using the formula. So the result, we will write it like this. Okay, this is what we got in the lab, but actual value is 1.5. Actual value is 1.5. So thank you. I hope you understood this experiment. All the best for your examination.